Okay. While waiting for all to come. Okay, so question, we have discussed the thermal conduction. So later, before we go on to the next part, the other convection and also to discuss through the convection and also radiation. Okay, so conduction involves the only part which involves the calculation. So look at question exercise. Oops. Is question number 13 we have done? Did we discuss question number 13? Right? Right, that's it, you know. How about the screen? No. Yeah. Laptop is. Because just now when down without slotting in my card, it appeared here. So I thought, okay, so fine. But then see here, I did not notice. Always got something problem. You know, I cancel, then I go back. Something wrong with this. Yeah, I need to call the ICT. But meantime, okay, if you have your notes, can you look at question number 13? Exercise. You can see over there. Something wrong with the screen. Good morning. So none of the screen is working. Wait, so meantime, okay, could you please look at question number 13, the example in the slide, at question number 14. Okay, so then, so 13 and 14. So one is just involving one conductor, the other one involving a combination of two rods attached together. Okay, I will just check with inform the ICT and come. Yeah. Question number 13 and 14. Yes. Okay, let's start with the discussion first. Okay, so ICT they will come to check. So we go to question number 13, which is a simpler one. Okay. Huh? So now okay. Oh, because just now, when I came in, without slotting the card, this screen already able to project. I haven't slotted in the card yet. Then when I noticed the others are not. Then I slot in my card also same. Question number 13, 14.
The device is turning on. Please wait a moment. 解锁引擎吹话筒。上锁。
Okay, look at the question. While the troubleshoot has been taken place, an insulated rod of uniform cross section, 50 centimeter diameter, has a temperature gradient of minus 1.2 Kelvin per meter. Look at the unit. Okay, so temperature gradient Kelvin per meter. So that is your dT over your d dT over your per meter. So over the distance. So dt over dx lah. Okay. Okay. Thank you. What was the problem? Okay. Okay. Then next time. Okay. So because I noticed first without plotting the cut, it has projected. So I must make sure always restart back lah. Okay. So okay. Okay. Thank you. Thank you. Thank you, Joel. Okay. So let's. I think I already started recording. Yeah. Okay. So the temperature gradient is a D capital T. Yeah? Okay, so temperature gradient is D capital T over dx. So this is the temperature gradient. It is given as minus 1.2 Kelvin per meter. Okay, it can be degrees Celsius per meter or Kelvin per meter, but usually we will base on Kelvin per meter because it is the standard SI unit that we use. Okay, so the diameter is given in a steady state. Okay, so always when we are doing a calculation, it has to be based on a steady state. So the thermal conductivity of a rod is 30 watt per meter per Kelvin. So that is the thermal conductivity of the rod. That's a constant K. Okay, so when it comes to this chapter, when you, in this particular part of conductivity, so you must know, okay, what are the symbols, okay, so which is referring to. Okay, so that is what you need to take note. You need to make a notes on that so that you are able to recall that towards the exam. Okay, so when you do the revision, okay, so K. So here we talk about K. Okay, so the K is the thermal conductivity. So find the rate of heat flow through the rod. So when you say rain, it is your the energy, which is the dq over dt. So you should able to interpret the thing, okay, correctly. So rate of heat transfer, rate is anything divided by a time. So rate of heat transfer, heat is actually the energy dq. So then you come to the formula. So then what is the formula? So you recall the formula that we have discussed. So what is the formula? Negative A A dt over dx. Okay. So that is the formula. So those who are at the back, okay, probably you may not able to see. So over here, so when I write that expression, okay, so the rate of heat flow, so the rate of heat flow is given by the formula dq over dt equals to negative Ka. Okay, so dt over the temperature gradient dx. So now you put in the values lah. So you have negative, your K value is 30. And what is your area? So what is your area? How do you find the area? Yeah, so it will be pi r squared. So the area here, you need to, sometimes it will be given. Okay, so sometimes you have to work it out use the formula. Okay, so because it is mentioned, it is the insulated rod of uniform cross-sectional area. Okay, when they give you a diameter, understood lah, it is a rod like this. So therefore, the area will be pi r squared. Okay, so pi r squared, then you work out separately. So the area will be pi. Your radius is 50. So then when you times by, so it will be 0.50 meter divided by 2 whole things squared. Correct? Okay, so that will give you the area. Then you multiply with the temperature gradient. Okay, so that is negative. So they give as a temperature gradient of minus 1.2. So then you must put it as minus 1.2. The negative here, it is already the original negative in the formula. Okay, so when the temperature gradient is given as negative 1.2, then you substitute as negative 1.2. Then you work out and see what is your answer. Okay, so don't expect me to substitute work out using you have the calculator. So please work it out and tell me the answer. So I already wrote all the values. So when you, what is the unit for this? Rate of heat flow. What is the unit? Hello? What is the unit? What is the unit for rate of heat flow? Yes? Yeah, I heard. Who? Who said? What is the unit for rate of heat flow? Joule per second. Yes, simple as that. Joule per second. Yes. So what is the answer now? Unit no, joule per second. What is the answer? 7. So you should get 7.1. Is that 7.1? Okay. 7.1. Okay, so fine. That's what's this? Okay. So this one is just referring to one conductor. Okay, when a heat which it is conducted through the sample. Now look at example 14. How many have already done the example 14? How many have done? One. I can see only one person raising the hand. The others, two. Two only. Behind that? Oh dear. Okay, come. Read through the question first. 1 minute. Read through. Understand what is happening. What is taking place here. I can hear a lot of other discussion. Please avoid that. Okay, so come focus on the lesson. We are on a week 8 ready. We are going to enter to the next chapter, the second last chapter, chapter 4. In fact, it is going to be more challenging, the next 2 chapters. And you will see that 50% of your final exam paper questions will come from the next 2 chapters. Including this chapter, the thermodynamics, it will be very close to 70% already. So very important. Okay, 2 rods A and B are same cross-sectional area. So their cross-sectional area is given as 1.0 meter square. So are connected in series as shown in the figure below. Determine the junction temperature and the rate of heat flow. So this is two different conductors. Okay, rod. And obviously the conductivity of the material is not the same. Why I say the conductivity of the material is not the same? Why I say the conductivity of the material not the same? Is that because they said, okay, 2 rods A and B? Is that because of that? Then why the 2 rods have they are 2 different material? They have a different conductivity. Yeah, the difference in the constant. Okay, the thermal conductivity of a material. So you can see the thermal conductivity of the material. Okay, so for A and B, okay, so is different. Okay, so one has 200 watt per meter per Kelvin. The other one has 100 watt per meter per Kelvin. Okay, so A looks like a better conductor. Okay, so it conducts more heat. Okay, so per meter. Okay, so for every change per degree Celsius. Okay, so that is to analyze the constant. Okay, how do we solve this problem? So in order to solve this problem, okay, so you need to understand that when heat is transferred across the conductor, so can you tell me from which direction? First thing you must identify that. So which direction the heat will actually flow? Is that going to flow from left to right or right to left? You see from here. Left to right or right to left? Or in a way, okay, is that from A to B or B to A? A to B. Why? Yeah, so A is on a higher temperature region, B is at a lower. So obviously the temperature, I mean the heat, okay, will flow from a region of a higher temperature to a region of a lower temperature. So it is going to be from 200, okay, so all the way to 110. So therefore, so we want to find the junction temperature. So just say the junction temperature is obviously, okay, is going to be somewhere here. This is the junction temperature. Okay, and then you have the temperature. Here I can put it as TA, and then at the end here I can put it as TB. This is for the purpose. You can use a different symbol if you want to. So the question already mentioned same cross-sectional area. Okay, are connected series as shown in the figure. Okay, so determine. Okay, so whenever when you do the calculation, we assume okay, so the rate of heat transfer is average to a constant. So therefore, I can say that the rate of heat transfer, okay, so which is the dq over dt for A is equivalent to dq over dt for B. Because the heat that transfer from the region which is a higher temperature, okay, to which is from a TA to the junction temperature, and from the junction temperature to TB, it must have a constant rate. It's like a straight line. Okay, so but straight line, but then it may not be a exactly okay. So something like this. If I plot a graph, so from 200, okay, so sorry, what was temperature 200 degrees Celsius, it drops. Okay, so maybe here this is the junction temperature. Then from that, it's also going to drop, but the gradient is different because we know that you notice that the KB, okay, so is different than the KA. So the rate, I mean the rate of what's that? We can value will different, but then the transfer will be the same. So therefore, in this case, since we come to this assumption, the heat rate of heat transfer across the conductor is the same. Now you recall the formula for the dq over dt equals to negative Ka dt over dx. Now you use this formula. So could you try to substitute the values first and try solve? Those who have not done, okay, can you please try? So you will have on your left hand side and also your right hand side. Okay, so you have your dq you work it out, don't depend on the answer I'm writing here. So you can't work together with me. So you have over dt for A, it should be equivalent to dq dt for B. So then you'll use the formula. Okay, so this is to substitute the values in accordingly. So you have negative. The K for A is 200. The A area is 1. Okay, it is made easier here. Then your temperature gradient. This is where you need to be careful when you substitute your values. So the dt over dx temperature gradient, the dx for A will be 0.25. But how do you going to write for the change in the temperature? The heat flows from TA to the junction. So junction is the final, correct? TA is the initial. So you must take the temperature at the junction minus temperature at the A. Okay, so notice that some difficulty. Okay, so looking at it here. Okay, so I will try to just fit it in over here. So I have the temperature, junction temperature here. So therefore, I have the negative 200 multiplied by 1. Okay, so then temperature at junction minus 200 divided by 0.25 equals to, oops, minus, hello, why always late? You can buy the bread earlier.
Sorry, this is the last time.
Okay.
Okay,
Mm.
promise.
Okay. It's not that, I mean, coming late, okay, so I feel bad you miss me information, whatever I shared earlier. Okay, so then here your TB is final. Okay, so which is minus the temperature at a junction over the, oh, what is that? Oh, 1 minus, okay, 0.75. Correct? Okay, and then TB is 110. So I can substitute straight here. Okay, no need to write another. Okay, 110. Okay, I think all values have been substituted correctly. Oh, I forgot to have, sorry, I missed out something here. Okay, so I need to take out this all. So we need to multiply 100 multiply by 1, then only you have your 110 minus the temperature at the junction divided by 0.75. Okay, so now you work out to find your temperature at the junction. Go. Now I leave you to do the calculation. See what is your answer. Yeah? What's the answer? What's the answer? Some things you can simplify already. Okay, so on your left and right, 200 divided by 100, you get 2. Okay, times across, simplify. Okay, move the temperature junction to one side, to the left hand side, other numbers to the right hand side. And what's the answer? Marcos, you have done? What was the answer? Yeah, why? What was the answer? Yeah, what was the answer for A? Huh? 100? 187. Okay. So, to be exact, you get 187. But when you round it up, okay, so you can round up to 190. Okay, so you get 187.14 something. Okay. So 187. Okay, so because we worked, you find the temperature gradient. Okay, so you maintain, okay, so this in degrees Celsius. So eventually you are basically working out the answer in degrees Celsius. Okay, so then you can round up to 190 degrees Celsius. Okay, so that what you do get. Then B, rate of heat flow. So the rate of heat flow. So if you want to find the rate of heat flow, it is so if you plot a graph of versus dx, sorry. That's my, if it is a graph, you plot against the time. Rate of, this is versus the distance, okay. But if a graph is plotted, heat versus the time, then the rate of heat flow, actually you get a straight line. Okay, so the gradient here and the gradient here is same. That's what we actually use this now to solve. So when you are referring to the, okay, so this is, okay, sorry, Q, joule, and this is, so the rate of heat transfer is the same. So this is the junction temperature. So it is just a straight line because we understand that it has reached to a what you can say in equilibrium, okay, constant heat transfer. So based on that, so we understand the rate of heat flow, whether you calculate based on the rod A or you calculate based on rod B, you should end up getting the same answer. Okay, I can work out based on A and B. So if this is on A, this is B. Try to work out and see. If I use A, then dQ over dt equals to negative, okay, so 200 times 1 and junction, okay, so 187 minus 200 divided by 0.25. Okay, see what you get. See what you can get. And then the answer here, you try to compare with this for B. Same formula. But now it is negative 100. 1. Okay, so you have 110 minus 187 divided by 0.75. Compare the value for A and B. Are they same? If they are not same, then this is proof wrong. They should end up, okay, so same. So whatever the rate of heat transfer, rate of heat energy transfer for A and B is same because it has reached to a, I think in the first question they mentioned that. Okay, so uniform cross-sectional area, steady state. So it has already reached a steady state. In the question, didn't mention. But then obviously we need to base on a steady state. Do you get the same answer? Okay, so what I did is, okay, so I'm just sketch on the those who are at the back if you're not able to see. So you have a graph. Oops. So you have a graph. The Q joule versus the time in second. So it's basically you have a straight line and you have a junction temperature here. Okay, so that's basically at the junction temperature lah. Okay, so therefore this part is material A and here is the material B. So for material A, just now we made the conclusion the rate of heat transfer for A is equivalent to the rate of heat transfer for B. So with that, we have found the temperature for the junction. But now I want to find the rate of heat transfer value. Just now we just assume it is same, then you find the junction temperature. So now dQ over dt for A is equivalent to minus 200 times 1 junction temperature 187 minus 200. Okay, so divided by 0.25. And for dq over dt, B, need a space a bit. So it will be minus 100, 187, oh sorry, 1, it was 110. 110 minus 187 divided by 0.75. Okay, can you give me what was the answer for the rate of heat transfer for A? What is the answer? Rate of heat transfer for A. Yeah? 10,000. 10,400. Oh, okay, okay. Yeah. 10,400. Okay. 187 something. Okay. Because some depends on 187 or when you use a rounded up value of 190. Okay. So, but then when you compare the value for A and B, what you can say? Is the value almost the same for A and B? Similar, correct? So almost the same. That's supposed to be. But because of the decibel, okay, I'm not sure. Okay, so because if you use the 187, okay, so then probably you get it is close to 1,000, I mean 10,000. Okay, so 10,000 joule per second. Okay, so 10,000 joule per second. So you notice that for A and B, the rate of heat transfer is the same because it already reached to a steady state. Okay, so take note of that. Okay, so move on. So I hope I have spent enough time with this. Okay, so question, extra question. Okay, so you try. I think I did give you the answer for the extra question. Okay, right? The extra question. So the thermal conductivity 1N, okay, is 25. Okay, so I did give the answer for this. So for A, okay, so maybe later I can just, yeah, so this one I given you the, so for A, okay, so the answer should be minus 400 Kelvin per meter, because that is the temperature gradient, Kelvin per meter. Then the temperature at the point 5 centimeter from the hotter end, that is the temperature of the junction. Okay, so it is 80. So temperature at the junction, so equivalent to 80 degrees Celsius. And the rate of heat transfer, okay, so that is joule per second. So that is 30.4 joule per second. Okay, done. So that is for 15. Okay, so and then the base area, this one I gave the answer is the 379. Okay, so that's it for the exercise part. Okay, move on to the second type, second way of heat is being transferred from one region to another region. So the conduction had more discussion related to the formula. So for the convection is more of just a points theory. Okay, so I will just go through very fast with this. So when talk about convection, transfer of thermal energy by mass motion of a fluid. Okay, water flow, okay, air, hot air flow. Okay, so it has to be a transfer of a mass, okay, the medium. Okay, so from one point to another point. So these are some examples that you can actually see. So convection that takes place. Warm water color moves by convection. So you'll notice that the color substance, okay, so move upward. Okay, so and then this will produce a flow. Eventually, the whole solution will change to the color. In chemistry, you have potassium permanganate, which is the purple in color. So when you drop it, okay, so that causes the process. But this one has to when you're referring to a warm water. The other one is actually osmosis. This is more of a biology. Okay, I don't want to get confused with that. Okay, so the other observations that you can see, these are all different observations. Okay, so example that explains about the convection. Okay, so you can this one all you can just read through. Okay, so naturally you can see the convection also takes place when you talk about in terms of sea breeze, hurricane, and so on. The application. So you notice that the air from a cold sea breeze move to the land, then the warm air move towards the sea. Okay, so that produces a cycle. This is during the daytime, because daytime, okay, you notice that the land, the ground will become hot faster. So therefore, hot air goes up, so it will move to the sea, okay, and cool air from the sea will take up the space, okay, so that is left by the hot air, and it will work in reverse when you talk of when it goes to a night. Okay, so night the land will become cold faster than the sea. So therefore, sometimes you can notice during a night time when you walk, when you go to the beach side, when you walk into this, when you step in the sea water, you feel the sea water, it is warm. The ground will be more cooler. So then the sea breeze happens. I mean, then you have uh, a reverse land breeze. Okay, natural convection process. Okay, so I'm not going to talk, not teaching you on the geography part. So this is to understand a basic thing is the convection will always takes place. Okay, so when a hot air goes higher because in decrease in the density, cold air is more denser, it will come down. So this will produce a cycle. Okay, and this is what happens in the fridge. So all these are you can look into uh, the radiator, all that. I mean, sauna. You have a sauna system. Okay, so design such a way it can produce a flow. Then it comes to radiation. Radiation transfer of thermal energy in a form of electromagnetic waves and requires no medium. So it can transfer from any distance. No, because it does not require any medium. It can travel through vacuum. That's why, okay, so we are able to get the sunlight. Okay, because most of the space between the sun and earth is actually a vacuum. It is an empty space. So therefore, no trouble, no problem with that. Okay, so we are still able to get the heat energy transferred from the sun to the earth, okay, by radiation. I did mention our body to a certain extent also can radiate heat energy. Okay, so when you get hungry, you can really feel you are emitting some form of an energy. That's the infrared, low frequency infrared. Okay, so that's why when a person has a fever, okay, so when the body temperature goes 38, 39, okay, and that's where you can feel your body is warm, hot. Okay, so it is emitting infrared. So that can be detected by using the infrared detector. So they use the scanner, okay, to basically calibrate our body temperature. So they did that during the COVID time. COVID-19. Okay, so at the airports. But now it's going to be 2025. There is students. See, when you talk, tell me when you want to talk, then I will stop. Thank you. So they have actually used that to measure the temperature. So now, what I was saying, 2025, there is a outbreak of a new virus. Okay, so it's been informed. Okay, so which is going to be even the more dangerous or something. So be careful. Okay, so yes. Okay, so again, use of all these temperature scanners. Okay, may come into action again. Okay, so that's basically about the uh, thing. Okay, so this one you can just read through. So the last part we have discussed is just the understanding part. Okay, so the thermal conductivity. Okay, so just to summarize back on what we have covered in this chapter, we started off with the first law of thermodynamics. So the understanding of the first law of thermodynamics and the second law of thermodynamics is important. Kinetic theory of gases. Yes, especially kinetic theory of gases. Okay, so understanding of that. Specific heat capacity, latent heat. Okay, so very important. You will find questions on the MCQ and also in the structure part. Okay, so thermal expansion also you will find questions on the structure part. Okay, uh, then the heat transfer is uh, yes, yeah, and that you will find some basic questions asking on that. Okay, so that is basically on the chapter 3. Any questions? Any questions? So I'm done for the chapter 3. So we will move on to chapter 4. Before we move on to the chapter 4, okay, so we take a short break. Yes?
The foundation.
Only.
Yes, now we still struggling what we can do. Because the pressure we can't really get the result.
Oh,
So we're just thinking how to get the pressure. So we just give ourselves release the chance. Yeah.
okay, okay. Wish you all the best.
Yeah, thank you, sir.
Okay.
Thank you, sir.
Okay. Okay. So before we go to the chapter 4, so it's a video, because the first part of your chapter 4 is to understand about the structure of an atom. But then, okay, so in terms of understanding the structure of an atom, okay, so there will be no questions will be asked on the structure of an atom. Okay, so therefore it is, that's why you can see even in the notes, it is indicated with a border line, which is broken line. That's actually basic things that you should know before we go more further into the discussion about nuclear physics. So you have, I think you have learned about this not experiment, learned about this idea, okay, experiment, Rutherford's alpha particle scattering experiment. So this Rutherford alpha particle scattering experiment was conducted by Ernest Rutherford, okay, under the supervision of Ernest Rutherford, Geiger and Marden, okay, a person who conducted the experiment, but they both of them were supervised by the Rutherford. So this was a breakthrough experiment that is conducted by Ernest Rutherford, which has brought to the conclusion about the modern structure of an atom. I think you know about that. I don't need to go into to explain that. So I'm not sure whether you have watched this video. So with this video, we can just summarize the understanding within the 2 minutes. Okay, what is the structure of an atom? The conclusion of it. Okay, observation. So this is for your knowledge. Then we'll go into the chapter. Okay, so we'll start with the video. Can you hear?
Lord Ernst Rutherford. Shown here is the diagrammatic view of the famous gold foil experiment conducted by Lord Rutherford. The radioactive source, rich in alpha particles, was kept in a thick lead block with a narrow opening. The alpha particles were confined to a narrow beam by passing them through a lead sheet with a slit. An extremely thin foil of gold was bombarded with these fast-moving alpha particles. The scattered alpha particles were detected using a rotatable detector, which has a microscope and is screen-coated with zinc sulfide. The whole experimental setup was placed in an evacuator chamber to prevent scattering by the air molecules. These striking particles caused scintillations on the screen. Based on the observations, Lord Rutherford deduced these conclusions. As most of the alpha particles pass through the gold foil without any deflection, most of the space within the atoms is empty. As some of the alpha particles were deflected by large angles, they must have approached some positively charged region responsible for the deflection. This positively charged region is called the nucleus. As very few alpha particles experienced a deflection, it was concluded that the volume occupied by the nucleus is very small. Since alpha particles, which are comparatively denser, were deflected by the nucleus, it shows that almost the complete mass of the atom must be within the nucleus.
Okay. So this was the conclusion of the alpha particle scattering experiment, which has led to the modern understanding of the structure of an atom. So first of all, why they use alpha particle? Because alpha particle is positively charged. And then if you heard, it is mentioned, they use a gold foil. Okay, so why they use a gold foil? Why could not get an aluminum foil or what? Okay, why they must use an expensive foil to do this experiment? Expensive material. Okay, gold. Anyone? That was not mentioned in the video. You don't find that information in your textbooks also. Okay, so why they choose gold foil? Gold foil. Is that they want to make it is one of the most expensive experiment? Why gold foil? So the reason why gold foil has been chosen is because gold is, one is a good conductor, is a metal. Okay, so it is a metal, and this is the metal. It has a low, you can say the, it's a soft metal. Okay, so when you compare with all the metals, okay, it is a good conductor, and in a way, it is a soft metal. Because it is a soft metal, it can be sliced to a very thin foil. If you are referring to other materials, it's quite difficult to have a very fine foil. So because they are able to prepare this foil, gold foil, so that's why they choose this. Because in this experiment, you need to have a very thin foil so that the layer of the number of atoms is minimized. Otherwise, there will be multiple, you can say multiple diffraction that will take place. Because when the alpha particle passes through the gold foil, if we have layer of atoms, then there will be a multiple diffraction. So very difficult to make a conclusion. So that's why they choose gold. Okay, so that's beyond the discussion. But our most important is based on this observation. Okay, you can see most of the alpha particles passes through the gold foil without any deflection. So most of the space in the atom is an empty space. Okay, almost about 99%. Only about 1%, okay, it is a high mass concentrated and is positively charged. So because of that, you notice these alpha particles are being deflected away. And most of the alpha particles, okay, so almost like 99% will pass through. Okay, only about 1% is deflected exactly. Okay, so more than 90 degrees. That explains there is a very high dense. Please, I can hear voices talking. Okay, so uh, so that is about this experiment. So the last conclusion, since alpha particles which are comparatively denser, okay, so were deflected by the nucleus. Okay, so I mean the alpha particle is denser. So since alpha particle has been deflected, so that explains there is something uh, high mass concentrated at the center. Okay, so of the atom, which is what we understand as the nucleus. Okay, so that's it.
Finding emails takes
Oh,
time,
sorry.
but not with Grammarly.
Okay. So now we are going into the chapter, nuclear physics. So the first thing that you see, okay, so in this, the nuclear structure, that is what we have discussed, we have seen just now, the structure of a atom, so nuclear structure. So once you have understood the basic things, nuclear structure, how do we, oh, sorry. Let me look. You should know that uh, when you are missing a lot of class, okay, so you are missing a lot of information. I noticed that especially those who misses a lot of class, you did not perform well in your quiz exam recently. It is still a case of not completing. So I will I will try to form I will talk to Dr. Chan and see if your piece paper okay, can be written to you to have a look, and then we can okay, so because if it is going to be large group, okay, so it's quite difficult to control. And anything you can further can explain during the visual session. Okay, so that I'll arrange okay, for the next week. Okay, so those class will be no problem. Okay. So if you are missing classes, definitely you are missing a lot of information. I can really see that. Okay. So in your results. So some have yes, yeah, and then okay, reason yes, you are absent. And if you have done the work to catch up with the work is good. So I can see many have done well. Okay, so as a score, so almost 90%. Okay, there is full marks also. Okay, so good, keep it up. Okay, the quiz question is set for based on a basic understanding. So it is should be able to score above the average. Mean okay, the range of average to a good. So I can see some students excellently have done, but still there is a large gap. There is also student did very poor. Okay, didn't answer the part B at all. But there is also students who got a party the marks. Okay, most of okay, so they lose 1 mark. So 9 out of 10. And there is also street where there is no answer for the party. It shows a large gap. Okay, it is not the question itself. Okay, so the question is the standard of an exam. But then, okay, your standard, are you are ready for the exam standard or not? Okay, so please check. So students, okay, so like Paris here. Okay, so make sure, okay, your attendance for the, we are on week 8, 9, 10, 11, 12. Okay, so make sure you ensure that the attendance, okay, so fulfill 4 June hand. Okay, so you have been absent quite a lot. Okay, so perhaps I may need to see you. Okay, so later possible, okay, so this talk to see me. Wait after the lessons. Lee Hong Ik. Lee Hong Ik. Yeah. Lee Hong Ik. What do you want? That. Oh, okay. Yes. Okay, so last 2 lectures you have please catch up with the work. Copy. Copy. Okay, so last 2 lectures after. Atul, Kim Atul is here. Absent. I don't know. Okay, so is Kim Atul here? Where's the signature is here? Kim. What is the point we put attendance? They are not able to perform in the office. Okay, so there's the attendance mark. Absent for the last 2 lectures, 13 and 14. Mustafa. Mustafa. Absent today also. Nurali. Absent. Ryan. Ryan. So they are not here, Ryan. The sign signature is here. Chia Sheng Jun. Chia Sheng Jun. Yeah. So the sign signature is here, but then Lee Wei Jun. Okay, so I've made some lectures. Okay, so catch up. Oscar. Absent. Okay, so Su Yanhen. There's no sign also, I think absent. Missing a lot. Tai Yushen. Tai Yushen. Okay, so you have missed quite a lot lectures also. Lecture 12, 13, and 14. If you are missing 2 like 1 week lecture, okay, so there will be a lot of information you are missing. Okay, you can say you drop 5 to 10% of your marks on final already. Okay, so if you didn't catch up. Yeah, I need to take time to check this progress before it is too late for you. Do you know not? For me to key in the attendance itself, it takes about 1 hour plus. Because so many absenteeism involved in a week. Have to key in. And our system, okay, so we need to key in. Okay, so one by one. Even though we try to use some way to do it faster, it's still because of the numbers are too high. Okay, every time, okay, so physical science 3, Chingich, Illa Iyasov Chingich. I don't see the sign today. They also absent. Ashel Kanak TZSL. Okay, so has been absent. Today also absent. Okay, so today present Anisha. Is Anisha here? Again, the sign is signature is found, but the person is not in the class. This is the second time I'm catching her. Signature also looks a bit different from the previous. Who else of friends is helping? Okay, so please, you don't be the person spoiling your friend. You are helping to sign, but then her education is point. You are giving a room for her to take a excuse from the lesson. You be a responsible friend. Lee Xuan Feng. Lee Xuan Feng. Oh, okay. So you absent lesson 12 and 13. So catch up your work, huh? That's what I'm looking at this. Earlier one, I don't know. Okay, based on halfway here, which has two absence, I just highlighting. Ayan? Ayan. Okay. So last two lectures you are absent. Adi? Adi? Okay. For Ayan, you have not signed yet. So no sign for today. Adi, I have not signed yet. Is Adi here? No? Okay. This is the class. Okay, fine. I didn't see much rate. Okay, physical science 4. Okay, so even there is, okay, so I can see Kong. Okay. Kong Hai Heng. Kong Hai Heng. Turn up for the quiz, but then after that, I don't see. You are boy? Oh, your name?
Sanjun.
Okay. Because I'm not sure. I was just trying to, I'm calling the names. So this class also, okay, physical science 6. Okay, so most of the time, okay, so fine. Okay, there is absenteeism, but then not as rate as some other classes. So physical science 5. Ashal Khan. Okay. You have missed last 2 lectures. Okay, so please catch up with your work. Adina? Adina. Adina. I think the signature is here, but the person not found. Where? Is it Adina here? Okay. Yeah, I hope the assignment work has been going progress. Okay, so you have up to second. Okay, so time extended to the midnight. Okay, so 23, okay, 59. Okay, so submission deadline, the submission in the Moodle already visible to you. Okay, so because I didn't want to make it visible earlier, because then you submit, then you have a mistake, then you want me to like remove. Okay, so I only allow one submission. Okay, so one file. Okay, so submission. So any details, I think you have been checking with me. Okay, so hope it is in progress. Well, okay, so finish that. Okay, so then you don't worry much about the assignment work and practical. Okay, I just wanted to base on some feedbacks. Okay, so on looking at my report, see for the practical feedback. Okay, so the answers that you have given. Okay, so we try to guide you as much. I think with Dr. Chang and me, we try to give you the explanation for the expand. Listen, please. The explanation. Okay, so for the answers, but how you present your report, it is from you. When you write your data, okay, so the recent experiment I see in the table, when you write the dice count. So the table you didn't the students, some students, the values are written very random. Okay, so the flow in the table, the values are is as a flow. It's not like a straight line. When you write, okay, so I don't see a proper way of writing. So you write in between of space, empty space. So make sure that you follow the standard format. Okay, write as you're writing a proper assignment work. Don't simply, I know time constraint is there. That's why, okay, so we don't ask you to end up on the same day or end up, okay, immediately after the experiment done. Okay, so in 1 hour time period, some practicals has been they have applied that. So we don't do that. We give you at least you have 2 days to do the normal report sheet. We already provide you the report sheet. So the full report you have 1 week to do. So we are being tolerant in that. So make sure the quality of your reports that you give is better. Graph, the reason graph plotted. The others, I'm not sure. So, okay, so I did mention you need to draw a smooth curve, okay, for the practical 5. So some graph is really, uh, what's that, out of the shape. Okay, so exponential, but could not get a smooth curve. Then how you going to find the half throw and so on? So make sure that for the remaining practicals that you have, 6, 7, and 8, okay, so make sure you write your report clear, okay? So, and think someone is going to read your report to mark. Keep that in your mind, okay? So someone is going to read your report to mark. So don't feel bad, okay? So if you are not able to score much. Okay, so because practical is something, okay, we give you the answers, we discuss a lot of things. So you should be able to score, okay, so high enough for your practical report percentages. So that will be very helpful for your the 50% contribution. Okay, the quiz for TMP. Okay, so it is in my mind when I design it, I want to ensure that many students can secure a sufficient 10%, which is allocated for the quiz. Okay, so it's not that I'm testing, okay, to a level you understand. So I'm testing the basic and keeping in my mind, I want to ensure that many able to grab as much of percentage possible. Okay, so that your accumulated for your continuous assessment will be enough to push you. Okay, so to help you during your finals. I know you have 2 physics paper in the semester. Okay, so please, what's that? Incorporate. Okay, you are working for yourself. Be more responsible. Okay, so sorry, I have 5 minutes more. Okay, so let's continue. So whatever I wanted to mention, I did mention because this is already past the second half of the semester. So I need to do that. Okay. So we have seen the video just now, the structure of an atom. All this is I'm going to skip. So this is what we discussed. So as I mentioned, this is to introduce the idea of the structure of an atom. So the video later, the video that you watched just now, okay, so maybe some came in late. I will just share in the Teams. And for the experiment that you have done this week on a spectrophotometer, I did share a video referring to that instrument that is conducted by another person. So you can watch that video. So there is more explanation that is given there in the process of calibration and so on. Because during the actual practical section here, we are a bit rushing because we have only one instrument, what's that? A photoelectrometer. Okay, so therefore we need to wait. Okay, so in the queue to get the to analyze the transmittance of the wavelength when it passes through a medium. So therefore, you can watch the video. The groups which the practical has not over. Okay, you can watch that video before we go for the practical session. You'll have a better understanding of that instrument and also the experiment about when you read the instructions. Okay, so again, all this skip. That's why you can see it is a dotted line. Okay, so which is not, it will not be covered in your syllabus. I mean, it will not be tested for your exam. It is the basic things for you to know. Okay, now you can see from here, you don't see the dotted lines. So here you need to understand because this is where we are going into to discuss about the stability. Sorry, always I didn't realize. Okay, so I mean, my voice through the mic. Maybe you all can hear. If you cannot hear, please, those at the back, raise your hand. Okay, so in case sometimes when I talk like this, can hear at the back? Can, okay. So sometimes I don't realize because when I speak, okay, so loud enough, okay, so I can feel, I can hear, it is loud enough, but then probably it is not through the mic. Okay, so when I talk about the nucleus, okay, so an atom, if you look at it, for an atom, the diameter of an atom is about 10 power of minus 10 meter. That's the typical value. So when we refer to the diameter of a nucleus, it is about 10 power of 14 or 10 power of 15. Okay, a typical value, okay, I will say somewhere about 10 power of minus 15. So when I do a comparison between the size of an atom and the size of the nucleus, so the size of the nucleus is power of minus 5 times. Okay, so I mean smaller. Okay, so when you take this off or when you take the diameter of an atom, you will divide by the diameter of the nucleus. That's my pen. So if I take the diameter of the a diameter of the atom, and this one is the diameter of the nucleus. So when I take the diameter of the atom divided by the diameter of the atom over the diameter of the nucleus, you will notice that the ratio is about 10 power of 5 times, meaning the atom is about 10 power of 5 times greater than the nucleus. So that comparatively, you see how small is the nucleus. And inside the nucleus, okay, so the nucleus, inside the nucleus, you have nucleons, okay. So whatever that is found inside the nucleus is known as nucleons. And these nucleons are formed by protons and neutrons. Okay, so protons and neutrons are the one, okay, contained inside the nucleus, which is known as nucleons. So when you say nucleons, mean it is the protons and neutrons, not the electrons. Electrons are not found in the nucleus. Electrons are outside. Right? I think that one is the basic that you know. This is a very basic thing that you have learned. But in fact, when we go into more detail in the modern science, Okay, so in studies about the particle physics. So you don't have particle physics, we don't do particle physics. Okay, but this particle physics is a field where the things has been advanced nowadays. Okay, so whereby when you say particle physics mean simple example, we know proton, neutron. So you know proton, neutron are smallest, correct? But actually proton and neutron are not the smallest. Proton or neutron are not the singular. They are made of something else. So these protons and neutrons, okay, so they are not the singular. So for example, when you say proton, proton is made by another three smaller components, which is what we understand as the elementary particles. Okay, so I don't want to go into that. So you can go and Google and find. We have, when you talk about these particles, we can group them into what we call as hadrons and leptons. Okay, you will hear the sound hadron and lepton. Hadron mean heavy particle. Lepton mean light particle. You see the hadron H, heavy particle. Lepton is L, light particle. I will not ask you this in the exam. Okay, I'm just telling you so that further you can go and if you want to study about, you can find information about that. So these protons and neutrons comes under the hadron. Proton and electrons, okay, sorry, proton and neutron, they come under the hadron. Electron comes under lepton because yes, electron is it is known as the fundamental or elementary particle, some fundamental particle. Proton and neutron are not fundamental particle. Okay, so let's say the story goes lah. Then we talk about the leptons, other example, then the electrons, they call as quarks, up quark, down quark, meson, baryon. Okay, so many things. Okay, so that is not in your scope. Okay, so done. I just wanted to mention. So you hear something next time. Okay, so if you have not heard, then you are hearing from me. So you will when you next time when you hear, you will it will come to your mind. Oh, Mr. Subra have mentioned about this. Okay, so I think this is fine. 2 minutes past already. So these are the basic things I suppose you know. The proton, neutron, electron, the masses and charges. Anyway, it will be given in the exam if you are going to use. Okay, this is the normal nuclear notation. How do you write the nuclear symbol? Okay, wait loud. Another 3 minutes. 35, I will stop. Okay, so the mass number, nuclear number, atomic number. Okay, so the mass number, which is the nuclear number, always will be up. Then the atomic number, which is the proton number, will be below. You must know how to write the normal nuclear notation, how to relate between the nuclear number, proton number, and the neutron number. Okay. In fact, proton plus neutron, protons plus neutron, it gives you the nuclear number, correct? These are basic things you have learned. So you could go back, have a look on these basic things. Isotope, okay, read through the isotope. You have learned that before. You can go through the isotopes. Okay, then when you come in for the next class tomorrow, we will continue from here, which is the nuclear force and the stability. Okay, thank you.
Shut down in progress.